We talked about lists briefly while talking about for loops, and so we're going to hit the concept a little bit harder. What is a list? It's a sequence of values, like a series of names. Joe, Bob, Beth. There, we have 3 names. That's a list. Or a series of test scores, series of song files, series of, addresses in a contact list. A list of files to process. All of those are lists. A list is a sequence. 10, 20, 30, 40. That is a list of numbers as defined in this language. Here's a list of strings, a list of words. Spam, bungee, and swallow. This particular language is pretty odd because you can make a list of things that are different type. You can mix numbers and strings together, and you can even embed lists inside of lists. That's pretty idiosyncratic, specific to the Python language, so I'm not going to really talk about how to process things. Usually you're going to want to put data of the same type in a list. You're going to make the list all numbers or all strings or whatever. And yeah, Python lets you get away with not doing that, and if you're very careful in your programming, you can get away from it. But then if you go and work in another language like C++ or Java or something, and you're expecting arrays or lists to work like that, they won't. So let's pop open idle, and we'll play with some lists. So I'm going to do File, New. I'm going to do a save as and just call it July 10. Not feeling creative enough to give it a better name than that. July 10.
Here's a creative one. Jules the 10th.
That would work. Yeah, Julius. Yeah, I may have mentioned this before, but it always amuses me that the months September, October, November, and December are based on, Latin words for 7, 8, 9, and 10, but those are not the months, 7, 8, 9, and 10. December is our 12th, and November, 9, is our 11th, and October is our 10th. So, kind of an oddity of the way the calendar was developed. And then you have all the months that are named just because some Caesars thought it would be really cool to stick their own name, in the calendar. So the month of Julius, the month of Augustus, stuff like that. So let's put some months in. Months is equal to. Now when you define a list in this language, you use square braces. So I'm just going to type 3 letters rather than whole things. So you enter a sequence of values separated by colons. The colon, and not colons, commas. If you put the commas inside the strings, it would make it part of the data, and we don't want that.
What month is MON?
Pardon me?
What month is MON?
Yeah, I don't know what I'm doing. My brain is broken, guys. Let's do January, February, March. I don't know what I was doing there. Okay, and then April, etc. If you feel like doing more months, you can. If we wanted to print the first month out, computers start counting at 0. This is index value 0. So we would do this. Print months 0. Like that. You don't have to put the space there. So this would be index value 1. This would be index value 2. And this would be index value 3. What if we wanted to know how many items were in the list? You use the len function. It's a built-in function. A is equal to len months. And then let's print the length is followed by A. So in this poor calendar that I made, I only have 4 months. So besides lists of words, you could have lists of numbers. Scores. I'm going to give it a list of numbers. I'm just typing stuff in, making them up. There we go. If I want to get the total of those values, I can use the sum function. Total is equal to the sum of the scores list. If I want to get the average, it's the sum divided by the length of the list. So average is equal to the sum of the scores divided by the length of the scores. Right? Because if this is, say this added up to 100. If the sum of it is 100 and then there's 5 elements in it because it's 5 long, then 100 divided by 5, that would be an average of 20. Obviously, that's not the case there. So I may as well print the average. May as well print the total. Those are plausible. I'm not going to go and add them myself to check. Quite often you don't want to define your list. You don't want to just make a list at the very beginning of the program. Instead, you want to be able to add to the list. You know, you might want to let the user type in scores. Or you might have something that's, hitting a rainfall sensor to determine, how much it's rained in the past hour or something like that. And so you're going to keep reading in data and adding it to the list. That's not what this does. This is a kind of a predefined list. We just kind of hard code some values to it. But you can get input from the user and then add it to the list. So we will write a program that does that. So adding values to a list. Generally the process is something like this. 1, create an empty list. 2, use a loop where you get a value from the user or whatever, using input or whatever, and then 2b, append it to the empty list. Well, it's not going to be empty after you start appending to it. And then they'll loop, over and over and over until they decide that they're done. How do they decide that they're done? You offer them the choice like enter -1 to exit, or enter stop to quit, or you only let them type in 4 values, or whatever. So here's how you create an empty list. You do it just like this, but you don't put anything between the square braces. So we're going to wipe out our scores now. Scores is equal to, there, they're gone. Now let's ask the user for 4 scores.
How would you make it so they could choose the number of scores?
We could ask them. Very good idea. Let's do that. Num, standing for num scores, is equal to the input, how many scores to add. And then convert that to an int. Why an int in this case? Because the index has to be a whole number. You can't have 3.5 elements in a list. You can have 3 elements in a list or 4, but not 3.5. So now we're going to do a for loop for x in range up to that number. So if they type in num of 10, if they say that they want 10 scores, I think we talked about this, range, if you don't give it a starting value, starts at 0, and then it counts up to but not including num. So if you said 10, it would start at 0 and go up to 9. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 is in fact 10. So that would work for the number of scores to add. Let's give them some information. Input score number, comma, and then let's just print out x. So to say input score, 2, 3, 4, whatever. Now let's get a value from them. So I'm going to use the input statement. Since I already put my print right here, I'm not putting anything in the input statement like we usually did. Why did I do that? Because here's what I could not do and what I wish I could. Don't type this, but it'd be neat if I could do that. But the input function is expecting one string as its argument, not a string followed by a comma and followed by a number. So I can't do that, so that's why I put the print statement on its own line. All right, once you get a number, it'd be a good idea to convert it. I'm going to make it a float so that the user could type in a score, 99.3 or whatever. Value is equal to float value, and now we are ready to add it to our scores list. And I think the word is append. Scores.append that value. So we ask for the value, we convert it to a float, and then we tack it onto the list. Now you remember that code we did up here where we calculated the average and the total? Just cut those 4 lines of code and paste them again so you don't have to type them in. Just grab those 4 lines, and if you feel like typing them in again, you can. And then go and paste them down here. I'm going to run it to make sure I don't have any syntax errors. I think that's correct. Now when you run it, look at the input and the way that it says input score 0, 1, 2, 3, and 4. Well, your average user isn't going to be smart enough to understand why they're being asked to enter score number 0 because, people usually start counting at 1. So think about how you would change your program so that it would say enter score 1, 2, 3, 4, 5 rather than 0, 1, 2, 3, 4. It'd be really easy to change. I could think of 2 ways of doing it. Pardon me, Danny? Yeah, we could do a +1 right there. That'd be the easiest way. The other thing you could do is you could start your range at 1 rather than 0, but then you'd have to modify the second parameter, so it'd be 1, comma, num plus 1. But that's the easiest way, right there. All right, I do want to make sure everybody gets that running, so I'm going to pause and do walk-up. So if you're going to access the elements and you want a specific one, you put a number between the square braces. That's known as the index. We called it slicing earlier in another lecture. Slicing is when you get more than one number. Like if you wanted the first 2 test scores, and that's when you use a colon. Let's just go to the shell. Python shell, and my Python shell's got too much junk in it. So I'm going to close it and then do run shell again. And let's give ourselves a series of names, something like that. I don't know. Books is equal to, and I'm going to list some books. Math 101 is a book. Bambi. Goodnight Moon. We're covering all the classics. And Twilight. Here we go. Okay. So, now I have 4 books. Say I want to find out what the first 2 books are. I can use slicing. You know, if I did books, I'm going to sometimes say subscript 0 rather than say brace, 0 brace, or bracket, 0 bracket, just out of habit. There we go. So the first one is indeed Math 101. The second one is Bambi. But what if I want more than one of those? I do a 0 followed by a colon followed by 2, and that gets me 2 of them. The second number is one of those up to but not including things. So this starts at 0 and then it goes to 1, but then when it goes to 2 it stops. So that prints out 2 of them. If I want these, if I want that one and that one, I would start at 1. And what's my second number, the number after the colon, going to be if I still want 2? So it's going to be books, 1 colon, because I want to start here. But what is my second argument going to be? Not going to be 2 because that would just get me Bambi.
3.
Yep. That gets me Bambi and Goodnight Moon. So if you like thinking about it in terms of it goes up to but not including 3, that's totally cool, because that's technically what it's doing. It's starting at 1, and then it's going up to but not including 3, so it would hit that one, and then it stops at that one. What I do is I just take the difference between those numbers. 3 minus 1 is 2, so starting at element 1, give me a list that's 2, you know, Bambi and Goodnight Moon. I'm going to do the same thing, except I want it to go all the way to the end. Books 1 colon 4. So starting at element 1, and then the difference between those 2 numbers is 3. Starting at 1, give me 3 books. What if you didn't know the length of the list? You could use that length function to give you the list, to fill in that 4, or you can leave that colon off. No, you can't leave the colon off. You can leave the number after the colon off, like that. And if you do that, it says just go to the end of the list. Don't ever stop until you hit the end of the list. If you leave the number off before the colon, it means start at 0 and go up to but not including the second number. So leave the number after the colon off, it goes to the end. Leave the number before the colon off, it assumes the beginning. Now to me that's a little bit silly because wow, we saved a whole 0, you know, by skipping that. But okay, sure, it works. Then if you did this and you left both numbers off, you just put the colon. That's pretty absurd, but it gives you the entire list. So our textbook, this particular textbook may not call it slicing, but that is what's known as a list slice. A lot of other textbooks use that term. And I know we did that with strings, you know. And a string is kind of a list of characters, but now we're doing it with, you know, a list of words, a list of strings, or a list of numbers. The same syntax works.
Can you pick out like just the first and last?
Good question. How would I get the first and the last? I'm not coming up with a way. Without doing it twice, you know. You could say books 0. Be better if it wasn't off the edge of the screen.
Did you do 0, comma 4?
I'm sorry, I didn't hear the second part.
Did you do 0, comma 4?
Well, let's see what that does. Nope. Okay. Here's the only way I can think of it. Books 0 plus books 3. And that makes it look dumb. It doesn't look right. However, if you want the last element, a shortcut for using the last one, if you don't know the length of the list, you can do -1. And that gives you the last one, Twilight. So you can start counting from the end. -2 would be, 1 over from that. -3 would be 1 over from that. Now that is another idiosyncrasy of Python. You won't see that in a lot of other languages, but it's kind of useful. I want the last element of the list. I use -1. Why would I want to use that? Because otherwise I need to calculate the length of the list and subtract 1 from it. What do I mean by that? How long is this list? This list is 1, 2, 3, 4. But if I did this, books 4, it's going to be a runtime error. List index out of range. Well, why is that? There are 4 books. I ought to be able to print the 4th one. It's because it is 0 based. 0, 1, 2, 3. So if I wanted to print out the last book without getting a syntax error, and where it would work if the list was of any length, I would need to do something like this. Books, len, books, -1. Now that's really annoying, doing it like that. That would get us the last book, but it's a lot easier just to use that -1 argument like that. Sometimes you get data in the form of separated by commas, a single string. Something like this. Colors is equal to red, blue, green, orange, like that. And then you wish that that was a list. That's not a list. I can't just pull out red and then pull out blue and pull out green using a nice little for loop or using nice little indices or whatever. But you could split that list. Colors.split. Well, it wasn't a list. It was a string. But .split made a list from that string. What it said is I'm going to separate it at all the commas. Well, what if there weren't any commas in it? What if somebody had a list like this? I'm just going to use capital L is equal to, and I'm going to put some numbers in. 1, 23, 4, 5, 6, 7, like that. But you really wish that that was a list because you can't add those numbers together. We can't use sum, and calculate an average. But we could split the list. L.split. And I want you to split based on spaces, not commas. So I'm putting a space there as the argument to the split command. And that chewed up the list and chewed up the string and turned it into a list. So what's the difference? Well, if I print out just the list, it looks like that. I keep calling it a list. If I print out the string, it looks just like that. But then if I split it, see the difference? This is just a series of characters. The computer doesn't know what a series of characters is. You may have typed, the Gettysburg Address in there. It's only when we use split that it actually converts it into a sequence, of values that we can then process. We could get that number out. 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 This has still got a bit of a problem because although we wish these were numbers, these are actually strings. And we would have to convert them to ints. I don't think we're going to be using split much. But I just want you to have the idea that sometimes the user will type in data. Whatever they type in is always going to be a string. And then if you wanted to convert it into a list, there may be a shortcut if it's something that they all typed in on the same line. All right, if you try to use a floating point number as your list index, it'll yell at you. The list index must be an integer, not a float. The compiler doesn't look at it and go, oh, by the way, I guess 1.0 I could consider it a floating number because it's 0.0. It just rules it out instantly. Nope, you've got a decimal point in it. I'm not going to let you do that. If you try to access something that's outside of the range of the list, if you go too far past the end of the list, you get that runtime error, list index out of range. So I'm going to add a comment to this. I'm going to scroll back up here to where I had 4 months. Or maybe I'll just tack it onto the bottom. Yeah. Technically, you can access up to n-1 if the list is n items long. Yeah. So if you know the length of the list, if the length of the list is 4, you can get up to item number 3, 0, 1, 2, 3. If you ever actually used 4, you get a runtime error. So the index values can be 0 up to n-1, where n is the length. Or you can use negative index values to start at the end and work backwards. There are 2 ways you could write a loop. Well, there's more than 2 ways. I can think of 3 right off the top of my head. You want to print out the horsemen? War, famine, pestilence, death. Those are not very friendly, pretty ponies. So,
What are the next?
yeah. Here we go. For I in 0, 1, 2, 3. I would have just used a range statement. And then we print out horsemen at that specific index. You'll never see me do it like that. You'll see me use a range statement to do it. But that's not the only way to print out a list. You can also step through the list directly without using an index number, like that, with a for loop. Some languages have a for each command, or some textbooks call it a for each. For each item in the horseman list, print that item out. That's how you would think about that. So let's tack that onto our program. So emo for emotions is equal to love, hate, boredom. We experience all 3 of those things in this class. I'm kidding. Here we go. Now I want to print out every item in that list. I could do it like this. I'm going to do it 2 ways. For X in range, the length of the list, print that specific emotion out. I wish I hadn't done that. I wish I'd called it I. I like using I if it's an index counter, so I'm going to change those X's to I's. That's one way to do it, but there's a cleaner syntax. And I'm going to use E for element. For every element in the emo list, print that element out. Now, which syntax do you prefer? I like the second one. Faster to type, fewer than half of the characters. But they both work just fine. Let's test it. I'm going to say that I only have 1 test score because I don't feel like entering a lot of test data. Alright, so it printed love, hate, boredom, love, hate, boredom. It iterated through the list twice. This textbook calls this traversing. Traversing the list is starting at the beginning and going to the end. So this is traversing the list by range. And this one is traversing the list by element. There's a time when this is the better way to do it. And when would that be? That is when, I'm going to scroll this down a little bit so I have room to write on the board. Much to the bemusement of people watching a video and they can't see what I'm typing or writing. Say we had two lists. We have a kid list, and then we have a favorite food. We need to know what the kid's favorite food is, and we need to know what their age is. So we could define kids like this. Kids is Bob, Beth, and Billy. Definitely not in any alphabetical order whatsoever. And then their favorite foods. Bob is weird. He likes ice. Maybe that's not weird. Certainly is low calorie. Then, Beth likes candy. Billy likes kale. Something wrong with that kid's parents. Here we go. Nothing wrong with kale. I'm just making jokes. And then their ages. Bob is 10. Beth is 3. And Billy is 7. Okay, so we have 3 different lists here. If we wanted to print them out, if this is element 0, and this is element 1, and this is element 2, and then again 0, 1, and 2, and then 0, 1, and 2, we could not use this kind of list to print out all 3 of it in a nice format, where it says Bob is 10 and likes ice, Beth is 13 and likes candy, Billy is 7 and likes kale. You'd have to use that first syntax, where you have a counter, where you have an index number. These are what is known are parallel lists. Parallel because there are multiple lists of the same length linked thematically by the index number. Kid number 0 is Bob. Bob's favorite food is ice. Bob is 10, so 0, 0, 0 is our index values. Kid number 1 is Beth. Since food number 1 is candy, that means that Beth's favorite food is candy. Since age number 1 is 3, that means that Beth's age is 3. So you can see how these are linked together. So that's parallel lists. Let's do something like that in our... We had a list of months up there. I think I'm going to redo that though and just make a list of days. Days is equal to, Monday, Tuesday, Wednesday. And then now we're going to define 3 lunches. On Monday, I like pizza. On Tuesday, I don't know what I like. I like fish. And on Wednesday, I like salad. And then my drinks. With my pizza, I like water. With my fish, I like Kool-Aid. And with my salad, I like Coke. It's always the best thing to chase your salad down with. Okay. So we have 3 parallel arrays here. Multiple, I should not call them arrays. This language they're known as lists. Parallel lists. Multiple lists of the same length, thematically linked by the index numbers. Now I want a list that's going to say Monday pizza water. Or not a list. I want to print this data out. Monday pizza water. Tuesdays fish and Kool-Aid. Wednesdays salad and Coke. So I'm going to need a for loop, but I can't use it by a for element loop like that. Why? Because I don't have an index number, and these are linked by their index numbers. So I'm going to have to traverse the list by range. For I in range, hopefully they're all of the same length, or else they're not truly parallel arrays. So I can pick any array to get the length of. Let's print the days at element 0, the lunch at element 0, or not 0, that would print the same one every time. The days at element I, the lunch at position I, index I, and then the drink at index I. I think I'll add a comment to that. Display the parallel lists with a for index loop. So Monday was pizza and water. Tuesday's fish and Kool-Aid. Wednesday's salad and Coke. So you use that concept a lot. You know, you might have a series of days. You might have a series of students and then their test scores. No, that wouldn't quite work. But you get the idea, you know. All right, I'll wander around in a minute. I know that we've done a lot of typing and may have some syntax errors. It's also annoying when the program asks for data and we keep running that over and over and over. So eventually you start saying, I want 1, you know, score. I think the program would crash if I said I want 0 scores. Division by 0. So, too bad. We'd have to throw an if statement in there to prevent that runtime error. If the length of the list is equal to 0, then don't try to calculate the average. So the list length. len gives us the length of the list. Here we have the 4 ponies of the apocalypse. So len tells us 4. You can use the word in to check to see if something is in the list. I'm going to go back to the shell to demonstrate that one. Run shell. Now I have a clean shell because I closed it. I'm going to make some names. I'm just going to use capital L for my list because that's easy. Jeff, Bob, Sue. I'm going to find out if Jeff is in the list. Jeff in L. Yeah, that's true. Is Joe in the list? Joe in L. False. What do you use that for? Well, you know, you ask to, what is a user ID that you're editing? And then if ID in list, then you could do something with that information. But if ID was not in the list, then you couldn't. So that's what that syntax is for. You just check to see if something is in the list. Wish I kept the Twilight one. That was a good example. Paste in a notepad. If you want to add 2 lists together, you can concatenate them with plus. Here they define 2 lists. One list has the values 1, 2, 3. Another list has the elements 4, 5, 6. Now they make a list that is equal to the first list plus the second one. Then they print that list out and it prints 1, 2, 3, 4, 5, 6. Or if you use multiply, it repeats that list a certain number of times. List slices, we've talked about that. 1 to 3. 3 to the end. Lists are mutable, meaning that you can change their elements. What does mutable really mean? Well, I mean, it means you can change it. But say you had this, name is equal to Jeff, and then you tried to change one of those values. This would give you a syntax error, unfortunately. Oh yeah? I really wanted that to be a B. You know? No, that would be an error. Strings are not mutable. Meaning, strings cannot be changed. However, lists are mutable. So I'm going to make another list of numbers. L is equal to 3, 1, 4, 5, 9. I think I left a number out if I was trying to go for pi. But then I decide that I really didn't want it to start with 3. I wanted to start it with 6. I could say, okay, the first element of the list is really a 6. And then when I printed the list out, it would print 6, 1, 4, 5, 9. Like that. Now this is not, I mean, the reason I'm typing this in a notepad is so that we have future copy of it, and this obviously is not a Python statement right there. That would be the output. Print. So this one where we try to change the first letter in the string is an error because strings are not mutable. Change the first element to a 6. That is totally okay. If you are actually putting this into your Python code, it's going to stop your program from working, probably. If you have typed in something that's a syntax error or whatever, you can always mark off a section of code with the 3 quotes, like this. This is just kind of a foreign information. If there's a chunk of code in here that you wish wasn't working and you don't want to put a star in front of each line, not a star, a hashtag, you can use the 3 quotes like that, and that'll comment out a whole bunch of lines. So if you're mixing in notes and program code at the same time, that's one way to do it. Just cordon it off with the triple quotes. List deletion. You want to delete an item from the list, you use DEL. Here's your list. It says 1, 2, and 3, and then you do DEL 1. Well, that's item 0, so that's item 1. This removes item 1 from the list, so when you print it out, it's just going to print 1 and 3. Can you delete an entire slice of a list? Let's find out. Delete from my L list items 0 and 2. That should just leave Sue if that syntax works. Yeah. So you can use a range there. You can either specify a specific value to delete, or you can specify a range, a slice. It'll delete that many items.
Can you add?
You can add to a list by using the plus sign, something like this. L plus equals, and I want to add a new name to my list. Beth. Or you use L.add. 2 different ways to accomplish that. Both of those work. Well, that didn't work.
Well, that's kind of.
Oh yeah, look what that did there. That totally didn't work. Okay. And you don't use add, you use append. So you should not use plus like I just did. L dot append Sam. And then print L out. Okay. So that was kind of a mistake, me trying to use that plus equals to get to it. That would have worked if this was an honest-to-goodness list. Something like this. L plus equals parentheses, not parentheses, brace, quote Beth. Then when we printed L out. Why did it work like that? Well, because we're adding two lists together. We're concatenating two lists together. This is a list that happens to have one item in it. Since there's no commas or anything like that, it's just one item long. But that's okay. Whenever I add to a list, I do it that way. But if you wanted to add more than one thing, you could use that syntax. L plus equals Kelly, and then Kelly with an I, like that. Now we have two more items in our list. Kelly and Kelly. Cloning lists. Cloning is when you do this. A is equal to my list. B is equal to A, and then you get the entire thing by using the slice operator, the colon. Why do you do that? So that you could start making changes to one list without changing the other. We saw that lists are mutable. So that if you do A subscript 0 is equal to 99, then list A now is 99, 2, 3. We've lost our original data. But you can make a copy of the list by doing this, and then you could change B sub 0 to 99, and it would leave the A list alone. So I'm going to do that. List is equal to 1, 2, 3. And then if I do this, well, no, I'm going to make a copy of the list, but it's not going to be a copy. It's actually what's known as an alias. If I do this, A is equal to L, and then A sub 0 is equal to 99, then when I print L, it's going to print 99, 2, 3. Why is it changing L? I made a change to A, not to L. They are both pointing to the same thing. It's like you have two signs pointing to the same house. You paint that house red, it doesn't matter that there are two signs to it. You still have a red house. So this is what's known as making an alias of the list. A is an alias. But you can also make a copy of it known as a clone. C is equal to the list starting at element 0 going all the way out to the end. Now if you change one of them, like the second element, like the 88, if you print L, it's still going to have that first set of data in it. It's going to say 99, 2, 3. We did not manage to change that 2 to an 88 like that. And that was our goal in this case. We made a clone, a copy of the list so that the original data, L, was untouched. But then if we print the copy of it, it says 99, 88, 3. I hope that makes sense. That's not like the most important thing in the class, but you just have to make sure to realize that if you are changing data like that, you really are changing it. And then if you have two things that point to that data, you're changing it for both things. If you have two pictures of the same house, it's still the same house. You have two signs pointing to the same address, it's still the same address. If you call me Professor or you call me Jeff, it's still the same person. So if you throw Jeff down the stairs, you've also thrown Professor down the stairs. Don't do that. Okay, so list and for loops. For variable and list, do something. We've talked about that. We called that the for element syntax. For every element in the list, print that element. Now this is a really good syntax here. I love this syntax, but I don't demonstrate it in class because it's too easy to leave the S off. Friends is equal to Brad and Angelina, har. Joe, Zoe, Brad, Angelina, Zuki, and Dandy. And then for friend in friends, it's very clear what it's doing. Friend is an item in the friends list. But I guarantee if I type that up here, then people would be tacking on S's there and they'd be leaving it off there. So it's good syntax. I just don't demonstrate it up here for ease of correcting syntax errors. For every friend in the friends list, print that friend out. For every fruit in the banana list, print the fruit out. All right, guys, this would be a good point to break. Why don't we take a 5-minute break, get back here at 1:30 if you need to use the restroom or grab a drink. So a list can be a list of anything, not just strings, not just numbers. If you have a more complex data type, like turtles, you can make a list of turtles. Let's start a new one so that we don't have to keep entering data. This one I'm going to call turtle list. Import turtle. Let's make 3 turtles. T1 is equal to turtle dot capital T turtle. Parentheses in parentheses. If you forget the parentheses or forget the capital T, it'll mess it up. T2 is equal to turtle dot turtle. T3 is equal to turtle dot turtle. Now let's put them in a list. I'm just going to call the list capital L, which is equal to T1, comma, T2, comma, T3. Now we have a list of 3 turtles. Let's set the first turtle to red. So LZ.color red. L1.color is going to be blue. L2.color will be green. Now let's start them going off in 3 different directions. So L0 we're going to leave going the way he's going. L1 we're going to turn and go 120 degrees. Kind of like a triangle. L2 we're going to go another 120 degrees. So that turtle's going to start off at 240. Now let's make each turtle go forward 100 pixels. But let's do it with a for loop. I'm tired of doing this, addressing them individually. So for every T in the list, for every turtle in the list, T dot forward 100 pixels. Let's see if that works. I'm not totally sure it will. Yeah. Alright, this syntax is kind of crude. It'd be more awesome if we could, like, create a second list of colors. And then create a third list of starting directions. I kind of feel like changing our code to do that. So it's going to involve some deletions. I'm going to delete those 5 lines of code. And I want to make a list of colors. I'm just going to call it C. First turtle is going to be red. The second one's going to be blue. Third one's going to be green. I guess for consistency with the computing and TV world, I should have made it red, green, blue. It's funny, in elementary school you get told that the 3 primary colors are, red, blue, and yellow. But when you're talking about light on a screen, it's red, blue, and green. And their starting directions. S is going to be 0. The next one's going to start off at 120 degrees. The next one's going to start off at 240. So these are parallel lists again. Each one has 3 items. They're the same length, and they're linked thematically by their index number. If I want to process parallel lists, I cannot use the 4-element style syntax. Instead, I have to use the 4-index style. So for I in the range, you know what, I'm going to totally cheat and just put 3 there. That's not real cool, because what if I added turtles or subtracted turtles? I should make that the len of one of the lists. Alrighty, what do we need to do? We need to set the color of the turtle. So L at that item dot color C at that index. I'm going to delete the extra spaces. Also, their settings. Li dot turn left and go that particular angle at that particular index. Okay, that kind of worked. Let's not just draw a straight line. Let's make that a little slightly more interesting. Let's do T begin fill and then draw a circle. T dot circle 100. This may look really stupid. T dot end underscore fill. So each one of the turtles is going to do that. That's kind of neat. So the point I'm trying to make here are kind of twofold. One is that turtles can be complex data types. Not turtles can be. Lists can consist of complex data types. A turtle is a very complex data type, It's what's known as a class. It's got data and methods, functions. The data consists of the location on the screen, what color he is, what his current heading is, what his speed is, and then he's got functions like color, left, right, forward, begin fill, end fill. All of those are attached to what's known as the class, the turtle class. So each turtle is an example of the turtle class. And we made a list of turtles right there. Alright, I've forgotten how to make random numbers in this language. So I'm going to Google up. I'll bring that back. I know I typed too fast. Python random number. So I need to import a function, or I need to import the random class. And then I can use RENDINT. I should stick it up at the top, but I don't want to scroll up and scroll back down, so I'm just going to put it here. Import random. And then for every turtle in the list, repeat this command 10 times. For x in range 10, we're making a nested for loop now. I want you to turn a random number. T.left random.randint, starting at 0, going up to 90. And then go forward again. Another 100 pixels. Then I'm going to put a stop comment down here at the very bottom. I'll do walkabout, help correct syntax errors if this works. Alright, so each one's kind of going nuts. That's cool. I wish that I had made this one the outer loop. We have a nested loop. For every turtle, repeat 10 commands. But what I wish I'd said is repeat this 10 times. The reason I wanted to do that is if you saw what it was doing, you know, this turtle did 10 things, and then this turtle did 10 things, and then this turtle did 10 things. I think it'd be cooler if this turtle did something, 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 and then it kept repeating that. I also think it'd be cool if it wasn't always going left. This number, 0, wherever it was, to 90, I think I'm going to do it at negative 90 to positive 90 so that, you know, it has a broader range of movement. So I'm going to swap these two lines right here. For x in range, parentheses 10, that's going to be the outer loop. And then for every t in the L turtle list, do that. And I said I wanted to start my negative numbers at 90 and end them at positive 90. So it has a wider range of motion. I'm kind of tired of my circles, but I guess I won't comment them out. I should speed the things up though. Yeah, that's cooler. Maybe instead of 100 though, a smaller distance would be more fun. I'm going to change all these 100s to a smaller number, like 20, just so that it's not running off the screen so fast. So everywhere I had 100, I'm changing that to a 20. Yeah, that's more fun. Change this range 10 to range 100 so that it draws 100 different lines on each turtle rather than 10. And let's crank their speed up. T.speed. Nah, I kind of like it going slow. I'm not going to change the speed. Yeah. So we have 3 turtles wandering around. The reason that's possible is that each turtle is its own object. So each turtle is carrying around in its memory its own position, its X and Y position, its own angle, its own color, its own line thickness. Whether it's up or down, you know, pin up or pin down, whether it's in the begin fill, end fill mode, all of that kind of stuff. Whatever the shape is, one of our programs actually changed, you know, the little triangle to a turtle shape. Alright, now would be a good time to help syntax errors. Hit the text one more time. Okay, list methods. Append adds a number to a list. Insert. If you feel like inserting into the beginning of the list, you can do that. You want to reverse the order of the list, you can do that. You want to delete an item from the list, you can do that. Now that's not deleting by position. It actually deletes the number 12 from the list. But then when we printed it out, there was still a 12 there. Yeah, but there were two 12s in the original data. So let's make some notes about list functions. L.insert zero comma value would insert value at the beginning of the list. Delete L sub 0 would delete the value at the beginning of the list. L dot reverse reverses the list. How many times do you really want to do that? I don't know. L dot append adds an item to the end of the list. And in this case, in these cases, except for that one, we're using the parentheses rather than the square braces because these are actually functions. So whenever you have that L dot syntax, whenever you have a dot involved like that, you can be pretty sure that you're going to use the parentheses. And then lastly, L dot, I believe it was remove, yep, L dot remove, and then value removes that value from the list. I wonder if it gives an error if that value does not exist. Sorry, I'll pop that up. I'm just getting nervous, wanting to save the notes where we are. Alright, so we're going to create one more little program. Going to call it books. And just like we did with the Twilight list or whatever, we're going to do some stuff to it, but I'm going to put some comments to it explaining what we're going to do before we actually do them. Okay, I'm going to call this one books.py. So, create a list of books. That'll be the first thing I want to do. Then I want to append two more books, calling append twice. Reverse the list and print it. Remove a book from the list using dot remove, and then remove the first book using del, and then insert a new book at the beginning of the list using dot insert, and then print the list again. Apparently I did that in Notepad because nothing is being colored. Uno momento while I do that in idle. Alright. And this is awesome enough. I'm so proud of it. I'm actually going to put my name and the date. Alrighty. Let's do some of this stuff. Create a list of books. What do you want to call it? Books? Do you want to call it capital L? I think I'll call it books. Is equal to, just fill in some books. You don't have to choose the same things I do. Math 101. Python is fun. The ever popular Twilight. And Bambi. I'm going to take some spaces out so it all fits on the screen. Okay. Oh, and there's one I didn't show, which is sorting the list. Maybe we'll do that at the very big end of it. So append two more books, calling append twice. Books.append. Tarzan the Ape Man. And then Dracula. Why did I capitalize these and the rest of them I did not? I'm going to remove the caps just to make it not look dumb. Now reverse the list. Books is equal to books.reverse. Why did I do that? Because books.reverse makes the reverse list, but it doesn't actually change the original data. So if we want to store it back into the original data so that the original data is now reversed, we have to do that. Kind of odd we have to do that when in other places we don't. Like when we use .remove or whatever, you don't have to say books is equal to books.remove. Alrighty. Books.remove. I'm going to remove one of my books. Bambi. I'll never remove Twilight. Remove the first book using DEL. Okay. Delete books element 0. Now, since we reversed the list, I guess it's actually going to remove Dracula, because Dracula was the last thing I added, but then we reversed it.
So you won't remove Twilight, but you will remove the actual good Dracula.
Yeah. You're right. That is all kinds of messed up. All right. Insert a new book at the beginning of the list using .insert. Let's put Dracula back. Books.insert. At position 0. If you specified something else other than 0, it would put it at that position instead. I forgot to print the list up here where I said reverse the list and print it. So I ought to go back and add a print statement. But I'll do this one first. Print the books list. All right, I'm also printing the books list after I reversed it, so I just added this statement. Like that. Now it's almost inevitable that I've made syntax errors. Let's find out. Someday people are gonna forget about the sparkly vampires and I won't be able to get laughs with that line. I have to get something else. Invalid syntax, I certainly have. Oh, it's on my stupid comment here. I thought I'd get away with that. Add this line. Okay. Remove Bambi. Object has no attribute remove. I thought we saw that in our textbook. I have to flip over to the text to see. Huh? I don't get it. Let's take another look at what I did. Take a look at the error. None type object has no attribute remove.
Should it just be the number, place, number?
I think what I did is, after I gave you a big lecture about doing that, that was not correct. Where I said books is equal to, let me make this test first before I have you all do it. I guess that is sort of, okay. So my mistake, guys, delete that part that says books equals. I apologize for making a mistake. And due to me making that mistake, I'd better walk around and make sure this works. Okay, but while we're doing that, I'm going to make a little mini assignment. Create a list of movies. Could just be that same list of books, except I don't know of a movie called Python is Fun. Programming languages on a plane. Add 2 more movies, or append 2 more movies. Just like you used dot reverse, you can use dot sort. Reverse the list, print it, sort the list with dot sort, print it, remove the first item, insert a new first item, print the list. So this is actually a homework assignment, but I'm giving y'all time to do it in class. Won't take long, so let's go ahead and you can work on that while I do typos correction. So that's a homework assignment, movies.py. Alright, who had typos on the first of this stuff? But you did. Miracle occurred. All good back here? Okay. So I did not demonstrate sorting it over here. So I'm going to sort the list and then print it out as the very bottom thing of my original one. Sort and print. So on our original books.py, books.sort, and then print books. Looks sorted. That'll work. All right, I should have timed this difference so that we were close to the end of the class so I could say you could finish working on the movies assignment. Let me think about what we're going to do else. All right, the other part of the homework assignment is not going to be so easy because I'm not giving you, the syntax and then just having you repeat, something we just did. So, part B of homework will be and you can just put it in the same program. Create an empty scores list. And you do that, we've seen that syntax before. Scores is equal to, like that. And then using a for range loop, add 100 random numbers to it. Using randint, you can pick how big you want the numbers to be. Print the list. Print the sum of the list. Print the average of the list. Print the max of the list. We didn't talk about max. And print the minimum of the list. Now we've done everything except for the max and the min.
You want us to print the full 100 number list?
That seems excessive. Let's change it to add 10 random numbers. I was thinking about that even as I said it, and so thank you for prompting me. Okay, so that either won't take you hardly any time at all, or you'll get stuck on adding the random numbers. If you get stuck on adding the random numbers, ask me about it. How do you get the max of the list or the min of the list? You just do this. Print scores.max. That'll get you the highest value. Print scores.minimum. We demonstrated how to get the length of the list. We demonstrated how to get the sum of the list. Remember that you can use sum of the list variable. You can use the length. These are just built-in functions. I'm just going to use L to mean list. And if you have the sum and you have the length, you can calculate the average. All right. I will upload that. .max and .min even work on alphabet words, movies and books or whatever. They just sort in alphabetic order. Zebra would be the .max and antelope would be the .minimum, if you had a list of animals of every letter. All right. I really can't justify letting us get out this early, so let's Let's lecture for about 10 more minutes, and then I'll give you the rest of the time to do the homework, or if you run out of here, that's also okay. All right, let's just hit the glossary and consider it done. What is an alias? An alias is one variable that contains a reference to another object. We showed an example of that when we had two lists. We had a list named A, and then we set B equal to A. That made an alias to the A list. So when we changed B, it also changed A. Cloning creates a new object that contains the same value as the existing object. That's when you use that slice, but with a colon in the middle. C is equal to L square bracket colon. I think I'll copy these into our notes as we go along. I've lost my notes. Better save this. So L2 is equal to L1. L2 is an alias of list L1. Clone, to create new objects that have the same value, but what? That's too much. So L3 is equal to L1 with that colon in the middle, creates a clone of the list. Why do you care about the difference? If you change the alias, it changes the original. Whereas if you make a clone, it's like photocopying it. If you change the clone, it doesn't change the original. I didn't mention the word delimiter, but do you remember when we were using that split and we had commas? The commas was the delimiter. So if you do this, S is equal to, and we make a string, Joe, Bob, Sally, the commas are delimiters. So a delimiter is a character that separates items in a string to be split into a list. An element is one of the values in a list. For example, L sub 0 is the first element in the list. L sub 1 is the second. L sub negative 1 is the last. A slice is a subset of the list. L0 colon 2 are the first two elements of the list. L2 colon 4 are the next two. Guess we never gave a definition for a list. A list is a collection of elements. An empty list is one with no data yet. L is equal to that, creates an empty list. And we're going to do a little bit of rehashing on lists on Wednesday to completely burn it in. Two ways to print a list. There's actually more than that. To print the entire list on one line, you just use print list, like that. To print the list, one item per line, one element per line, use a for loop. For E in L, colon, print E. Or, nah, good enough. Nah, it's not good enough. Let's do the second way. This is the for element syntax. Now we're going to do the for index syntax. For I in range, the length of L, print L at that specific position. I guarantee that's going to be an exam question, and I guarantee that some people are going to make a very easy to make mistake. This syntax is so easy. About the only way you can mess it up is if you put L there. But that would just print the entire list multiple times. You had a list full of 10 items, it would print, 10 copies of the list. So instead you want to print the individual element. Here what people tend to do is if they put for I in range length of L, even if they get that right, they print I out rather than printing L subscript I. Why would you not want to do that? What would it print if we deleted the L subscript I and we just replaced that with I?
It would just print I a whole bunch.
Yeah, it would just print 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Why? I is the index. It's just a number in a range, starting at 0 and going up, to the end of the list. So if we made L, if we did print I, it prints 0, 1, 2, 3, 4, 5, however many items were in the list. Obviously, that's not what we want. So that's a for index syntax. When do we prefer the for index syntax? I gave a specific example. Gave several examples. When, it's okay if you don't remember, but when did we use for I in range in some of our recent programs? In the Turtle program. And when we did the days of the week and the favorite foods and the drinks or something, Monday we had pizza and water. You use the index when you're processing parallel lists. Why? Because parallel lists are when you have more than one list linked by the index number. And if you don't have the index number, you couldn't tie those items together. So let's tack that on as a comment here. Parallel lists are multiple lists of the same length where the items are thematically linked. By their index numbers. So flowers is equal to rows. This is going to be bad. Can't think of a lot of different flowers. What's another flower that's not named a color?
Daisy.
Daisy. What's another one?
Lily.
Lily. Yeah. Okay. And so the colors of the flowers. We're going to have black roses because we're feeling grim. Daisies are yellow. Are lilies white? Well, these are. Okay. There we go. So we have black roses, yellow daisies, and white lilies. If you're leaving, let me make a Dropbox for what we've already done, if you do not mind logging back in to upload it. All right. All right, there's a Dropbox M. Put at least one of the programs that you wrote today in it. Either the turtle list or the books list, or preferably both. Also, July 10 could go in there. Okay. So if we want to print that list, we're going to need the index for I in range of the length of one of those lists, like that. And then we could print the flower at that position, at that index, and we could print the color at that position. And so that would print rose black, daisy yellow, lily white. I will type these notes in a slightly prettier format so that it'll be easier to read. It's always a good idea to go back and review the chapter we just did. Alrighty, and we talked about list functions. What were some of the functions that we did on lists? Sorting was one of them. What else did we do? Yeah, we reversed the list.
We remove stuff from the list.
Yeah, we deleted and added items in the list. So append and remove, or delete. But delete's not really good enough. I'm not coming up with others that we did. I know we did more than that.
Did we add lists together?
Yeah, you can concatenate lists.
Just function?
So L new is equal to L1 plus L2. Like that.
Mr. Thompson, what exactly were assignments for today?
The assignments for today were, let me make that as a list. We did one called July 10. We did one called Turtle List, I think. Some variation on that name. And the last one was called Books.py. All right, I think that's enough. Want to use the extra time to work on your code? That's fine. I know some people will scamper out.